120 and the risk is equal to n, and nausea is bigger than 15 and so on and so forth, then this patient is a virus. And this happened 87% of the time. So we are about 87% sure that if this is the case, the patient will have a virus. So this is just an example how we go from the data to the knowledge and what this knowledge will look like. As I mentioned, we will talk about data types. These things here are examples of data types. For example, 32020, that's a numerical attribute. If it says negative or positive or multiple or obsessed or something else, that's a categorical attribute. Then I said over here we have dashes. Nothing is recorded. That's a missing value. And the last thing that we said is that this is the class attribute, bacterial, virus, or nothing, normal subject. That's what we're interested in. That's called the class label. So the data is rich, the knowledge is poor, and the reason we're saying that is because the data is big and the knowledge is small. So we have lots of data to go through, so it's rich. But the knowledge that we discover will be much smaller. So we will be learning how specific algorithms of how to acquire knowledge from the data and how we can implement these algorithms so to make them automatic. So we have data of large volume that is being generated by the different businesses during their operational, normal operations. Through our data mining processing, we will create information and knowledge, which knowledge can be used in the decision-making process. Not only the volume, so by going up, also the value goes up. So we have bigger volume, less value, smaller volume, larger value. So let's look now at the knowledge discovery process. How the process looks like. We gave definition of KDD. We gave one definition. And I said here, non-obvious hidden knowledge. And then we're trying to explain what this hidden knowledge means. So we have more information on that here. So non-trivial process of identifying valid and by valid we mean justified patterns and models, potentially useful, potentially useful patterns because what? We could go through all this data and we can discover that humans have 2 hands. Who cares? We already know that humans have 2 hands, right? We will discover that because that's a valid pattern that's in the data. Not just that, but millions of other things like this. So we need some post-processing step to go through the discovered knowledge and evaluate it. Is it valid? Is it novel? Is it useful? So it has to be novel and not something that we already know. And is useful, okay? What can we do with this? We just learned that if the patient has such and such exam results, then he has a virus or a bacteria. What can we do with this? Can we use this knowledge to accomplish our goals as a medical institution? Once we learn that the patient has a virus, we could probably do something like give them specific medication. But there could be knowledge that we learned that it's interesting to know, but there's nothing we can do. Like, for example, we discovered from the data that, let's say that was a space data, or weather data, or meteorological data, and it said the sun is not going to rise tomorrow. But there will be eclipse of the sun, no sun. It'll be dark tomorrow the whole day long. Is that interesting? Why is that interesting? Because it's not very likely to happen, right? If according to information theory, something's not likely to happen, then it's interesting to the user. So we could use some sort of interesting measures to go through these patterns and tell if they're interesting or not. How about useful? All right, this is super interesting. That's novel. But can we do something? Can anybody do something if the sun is not going to come up? We can't go out there and tell the sun to come up. I don't know. We have any technologies to make the sun come up if it didn't, right? So there's nothing we can do. So what the types of patterns we're looking for, they have to be of some kind of use to us. And they have to be novel and interesting and true. But they have to be valid and understandable. And understandable. Data mining oftentimes will generate this type of patterns and trends that don't make any sense to us at all. We can't understand them. Like, for example, from Walmart databases, they came up rules that were saying if the customers buy Coke, then they buy pizza also. Or if they buy pizza, they buy Coke also, 90% of the time, unless they buy Pepsi. That we can understand that. People like to eat pizza with Coke, okay. But then it came on and says, that was a famous one. If they buy beer, then they buy diapers. It's true, it's in the data. So, but does it make any sense to us? What does diapers have to do with beer?
You drink with your babies.
Maybe they want to get drunk because they're tired of their babies.
It's true.
I don't know. But we need to understand what the pattern means. If we can't understand it, we might just don't want to present it to the user. That's not good results from our analysis. So the KDD is looking for valid, novel, potentially useful, and ultimately understandable patterns from large amounts of data. How are we going to do all of this? We have a process that has several steps. That's the knowledge discovery process. And the data mining itself is just one step in the middle of that big process. So we will look at 5 steps here. First is understanding the domain and define the problems. So understand the domain and define the problem. We mentioned the reason we're doing this is because some organizations have collected large amounts of data and they want to accomplish their goals. Whether this is a medical institution, a financial bank, movie recommendation system, or music recommendation system, or whatever in the world we're trying to do, we need to define what is the domain or the field that the data is in, and what kind of problems we're trying to solve for these guys. So we are the data mining experts. We need to know in what domain the data is and what this organization wants to achieve with this data, so that we know how to help them. So first thing, understand the domain, define the problems. The second thing is collect and pre-process the data. So if the data is not collected, it has to be collected. In most cases, it's already collected because we have so much data now. And the reason we have, before we can actually do any processing, before we can run our data mining algorithms that will extract patterns